Okay, on this problem, we want to find the probability that the value is less than 75. The mean is 100 and the standard deviation is 10. So we need to get the z-score, and then we need to look up the z-score on the table and find the probability. So first, let's find the z-score. We want to take x minus the mean. We know that x is 75 here. So 75 minus 100 divided by the standard deviation. And that would be negative 25 divided by 10. So our z-score is negative 2.5. So since we want the probability that it is less than negative 2.5, whatever we look up on the table is the area under the curve. So the area to the left is the less than. So whatever we look up on the table is the exact number that we want. So let's look at our table here. Negative 2.5. See, negative 2.5 is 0.0062. What is the probability that the value is less than 95? You would do the same thing here, get the z-score like we just did, and then look it up. Let's go on down to more than, okay? What is the probability that the value is more than 130? We need to get our z-score, which is 130 minus the mean divided by the standard deviation, and that would be 30 over 10, which would be 3. So the value that we're going to look up is going to tell us of less than 3. So we're going to have to take that. It's going to be to the left of the z value. We are going to have to take 1 minus this area to get the area of the right side, the greater than side. So if we look up 3, it's 0.9987. So you have to do 1 minus 0.9987 and you get 0.0013. Same thing here. Changes to z-score, z-value, look it up on the table and do 1 minus that to get your answer. If it's great, if you need the area to the right, which is the greater than side, you have to look up the area to the left in the table and do 1 minus that area. All right, let's move on to question number 4. These are betweens. So what you have to do here is you have to find the z-values for each of these. So let's do that real quick. This is 6. Let me find my calculations that I've already done. So let's just do, since all these are the same types of calculations, I will just work the first one and you work the rest of them the same. As far as this number right here will be different, but the 126 and the 31 will still be there. And then you had 143 minus 126 over 31. So if you calculate both of those, you get negative 0.94 and you get 0.55. Okay, so you have to look this one up on the negative table and this one up on the positive table. Now, when we do this, let's think about it. Okay. Negative 0.94 is about, let's say right here, and then 0.55, let's say, is right here. So when we look up 0.55, it's going to give us all the area up under 0.55. So when you look that up on your table, you get 0.7088. 0.7088. Now, we don't want this area down here. So to figure out what that area is so we can subtract it, if you look up negative 0.94, you will see that this area down here is 0.1736. So if we want just the areas between these two numbers, we have to subtract that area out. So do 0.7088 minus 0.1736, and if you subtract those out, you will get 0.5352. You work the rest of them the exact same way. All right, moving on to question number 5. Let's see if it's okay. Question number 5 is a little bit different. Hold on, let me get off of my marker here. Okay, moving on to question number 5. It is a little bit different. We have P and N. Okay, so if you look at your formula here, if you ever want to know your formula, when you're using N and P, N is 100 and P is 0.80. So to find the mean, you're going to do N times P. And to find the standard deviation, instead of saying 1 minus P here, say N times P times Q and take the square root of it, okay? So what is Q? Okay, Q is the probability of failure. So to find Q, remember your P's and Q's have to add up to 1. So we know that P equals 0.73. So Q would have to be 0.27 to add up to 1. And then N is 155. So to find the mean, you do N times P. So 155 times 0.73, and you get 113.15. Now to get the standard deviation, you do the square root of N times P times Q. So multiply all those three numbers together and take the square root and make sure you round. Okay, so once you get those numbers, what is the probability of exactly 104 successes? Okay, so let me show you something here that's really important when you're working problems this way. And I kept writing the wrong number down, so be careful with that too. But when you're working these types of problems, for a normal distribution, only the probability for an interval can be calculated. To calculate the probability of an exact value, an interval needs to be created around that value. To create an interval for an exact value, subtract 0.5 from the value to find the lower limit and 0.5 add it to find the upper limit. So what you have to do is you have to kind of do it like we were doing the other one. So for 104 successes, we want to do 103.5 minus the mean. And I'll tell you what I just did. I kept putting 0.5 instead of 0.15, and that's why I kept getting the wrong number. So you're going to do this one, and then you're going to do 103.5 plus 113.15. Pretend that's 0.15 right there, divided by 5.53. So when you do those in your calculator, I believe you get negative 1.75 and negative 1.56. Hopefully that is right. Then once you look those up in your values, you get 0.0401 and 0.0594. Remember, we want the probability that's in between these two numbers. So remember, this is the area under the entire curve. But we don't want, here's negative 1.56 and here's negative 1.75. Okay, now when I got the area under the top one here, that is from here all the way back. We don't want all of that. We want to subtract out the area under negative 1.75, which is this. So take 0.05, I believe it was 0.0594 minus 0.0401. I'm going to double check this to make sure. And you get 0.0193. So I obviously didn't go back and correct my number. So double check these and make sure, but it's supposed to be 0.0184. I probably copied a number down wrong. 103.5 minus 113.15 divided by 5.03. I'm checking it real quick. Okay, that is negative 1.75. And then 103.5 plus 113.15. Okay, I'll have to go back to that one and check it, but go ahead and understand that you work it this way, and I'll have to go back and check for my error on that one. Okay, the probability of less than 124 successes. Less than is pretty easy because you just look up the value in the table. So let's see if I have that one worked. If I don't, I can just work it real quick. So you would have 124 minus 113.15 divided by 5.53, and you get 124 minus 113.15 divided by 5.53. You get 1.96. So if you look that up on the table, 1.9, 0, 1, 2, 3, 4, 5, 6. 1.96. You get 0.9750. So obviously, okay, 124 minus 1. Okay, this is where we have to do the interval. So instead of it being we want it to be less than 124. So we have to use 123.5. We want it to be, we don't want it to include 24. So you have to do that divided by 5.53. Now I found my note on that. So you get 1.87. And then if you look that up in the table, 1.87, you would get 0.9693. And then more than 102 successes, what you would have to do there is you don't want it to include 102. So you would have to do the interval again, and you would have to do a little bit above that, 102.5 minus 113.15 divided by 5.53. And if you divide that out, you get negative 1.93, I believe. Negative 1.93. And if you look that up, on your table, let's see if we have enough time. Hopefully we won't run out of time here. If you look up negative 1.93 on your table, you get 0.0268, but that's the less than side too. So to get the greater than side, you say 1 minus 0.0268, and that is how you get 0.9732.